us discuss about the minimization of DFA. Here Q0, Q1, Q2, Q3, Q4 are the states. Q4 is the final state and Q1 is the initial state. A and B are the input alphabets. So we have to minimize the number of states in this. For example, first we have to draw the transition table of it. Q0, Q1, Q2, A and B. So here Q0 is going to Q1 on A. So Q0 on A goes to Q1. Q0 on B goes to Q0 on B goes to Q2. Q1 on A goes to Q1. Q1 on A goes to Q1. Like that we have to fill this transition table. For the initial state we have to use an arrow, and for final state we have to round it. So we have to continue a particular process till pi n is equals to pi n plus 1. See, for example, here let us take pi naught. In this we have to write the final state and then the initial states. What is the final state in the given diagram? It is Q4, right? Q4 is the final state, and the non-final states are Q0, Q1, Q2 and Q3. Now what we have to do is, in these Q0, Q1, Q2 and Q3, which state goes to Q4? Like, check the transition table. Q0, Q1, Q2, Q3. Does any state go to Q4 in a transition? Q0 no, Q1 no, Q2 no, Q3. Q3 on B goes to Q4. So we have to keep Q3 in separate places. So now Q4, Q0, Q1, Q2 are the non-final states, and Q3 is considered as final state because it has Q4 in B. So here Q4, here Q3. Now remaining Q0, Q1, Q2. Now check if any of these non-final states, Q0, Q1, Q2, has Q3 in its transitions. Q0, Q1, Q2. Q1 has transition Q3. So now we'll separate Q1 also. Now we have Q4, Q0, Q2, Q1 and Q3. So here now we have to check if this Q1 is in Q0 and Q2. Q1 is present in Q0 as well as Q1. So what will happen if we separate Q0 and Q2 also? We'll just get 5 individual states, that is Q0, Q1, Q2 and Q3. What is the use of 5 individual states when we wanted to minimize it? So if we have 5 individual states, again we'll just get the same transition table and same transition diagram, right? But we don't need that. So what we'll do is, we won't separate it. We'll consider it as non-final states only. We won't divide it further. We'll stop here. So now we can see that pi 2 and pi 3 are equal. So here we are going to stop the process. We won't. At pi 3 we got the minimized states as Q0, Q2, Q1, Q3 and Q4. So now we have to draw the new transition table. We'll take Q0, Q2 as a single state, and as the initial state Q1, Q3, Q4 as the final state. So on input alphabet A and B, we have to write the transitions. So Q0 on A goes to Q1, Q2 on A goes to Q1 as well, and Q0 on B goes to Q2, Q2 on B goes to Q2 as well. So we'll just write Q1 and Q2, and remaining we'll be writing as this Q1, Q3 and Q4. So for this we have to draw the new transition diagram, that is Q0 and Q2 will be considered as a single state. Q1, Q3, Q4 are like just normal transition diagram. Now we have to draw it. That's it. Thank you. Just one more clarification. If we have 2 final states, then these will be the final states. Here Q1 and Q2 are the final states, right? So take these as the final states and take Q0 and Q3 as the non-final states. Non-final states, and these will be our final states. Now check if these non-final states have these final states in their transition, Q0 and Q3. Q0 and Q3 has Q1, Q1 and Q2. So we'll split this further. So Q0 and Q3. Do we have any more states to split them? No. So we'll just stop it here. So the next pi will be the same. Here pi 1 is equals to pi 2. So we'll stop it here. So based on this, we'll be drawing the new transition table and new transition diagram. That's it. Thank you.